Hello folks, in the previous lesson we learned how to compare numeric data and use branching to run different code based on the result of comparison. In this lesson we will learn how to compare strings in programming, so let's get right to it. So first of all, as usual, let's copy the code we wrote last time. Create a new file, paste the code, but this time let's not delete all of it, let's keep this part. Alright, so if we run the code, we will see by in the console, which happens because the characters A and B are not equal. And if we compare, say, A and A, we will get high. Pretty straightforward, but it gets less straightforward if instead of comparing characters, we compare strings, like this. We still get high in the console, but this time we also get a warning, which means that something isn't right. Now let's see what will happen if instead of literals we compare variables, like this. Well, this time we get just high, no warnings. Now let's see what will happen if we use array variables, like this. Well, this time we get a warning, and we see by in the console, which means that the data pieces associated with the variables are not equal. So what the heck is going on here? Well, this has something to do with how strings are managed in C, and the good news is we're not going to talk about that. The main takeaway here is that we should not use the comparison operators to compare strings. Instead, just like this warning suggests, we should use a string comparison function. Before we do that though, let's talk about functions in general. So far we used two functions, printf, that you can see here, and scanf that we use to take user input. Now there are essentially two things you can do with functions. You can create them, and you can use them. Creating a function is called declaring or defining a function, while using a function means calling a function. Here, and here, we're calling the printf function, which is defined somewhere else, meaning not in our code. Now where is it defined? Functions in C make up libraries. A library is simply put a file that contains a bunch of functions. If you want to use a function defined in a library, you need to include that library in your code. And we do include a library named stdio here at the top of our code. Now this stdio stands for standard input and output, and it contains functions that can be used for input and output, such as scanf and printf. And if we remove this include and try running the code, we will get an error saying that we're trying to call an undeclared function. So again, functions can be declared and called. Functions can be created by someone else and added to a library, which allows us to use those functions in our code, like we do with printf and scanf functions. To be able to use a function that belongs to a library, we first need to include that library in our code, which we can do by adding this include directive at the top of the code. Alright, now how do we create functions? Well, creating a function usually involves two things: declaring a function, which means writing its header, and defining the function, which means writing its body, or simply put, the code that the function will be associated with. Now here we have a function named main. This is the function's header, and the body or the code of the function goes inside this pair of curly brackets. The header of a function consists of three parts. First comes the return type, then the identifier or the name of the function, and finally inside round brackets come arguments or parameters. Our main function has a return type int. Its name is main, and it takes no parameters. Now, before we move on, there's one thing about this main function that I would like to mention. Any C program must have a main function. When running code, the computer calls the main function, and without it, the computer will not know what code it has to execute. Now let's look at the body of the main function. You probably remember that the code we write must go after this opening curly bracket and before this return 0. This return 0 is a return statement. It consists of the word return, followed by return value, which is data, whose type must match the return type of the function indicated in the header of the function. A return statement tells the computer to output or return some data and terminate the function. So the reason why the code we write must go before this return statement is because this is where the execution of the function will stop, meaning the code we write after the return statement will never be executed. Now to make it a bit more practical, let's write our own function. Please note that you cannot declare a function inside the body of another function. So to create a function outside the body of the main function, we need to write the function header. First goes the return type. Again, it can be any data type, but let's have our function return an int. Next, we need to specify the identifier of the function, which should be unique, meaning it cannot be main since we already have a function named main. Let's name our function compare. lowercase. And finally, inside round brackets, we need to specify the parameters that our function will take. Specifying function parameters basically means declaring variables. Let's have our function take two int variables as parameters. So inside the round brackets, we declare two int variables and separate the two with a comma. And finally, we add a pair of curly brackets for the body of the function. Please note that we did not need a semicolon in front of the opening curly bracket. What this function is going to do is it's going to compare the values of a and b, and if a is less than b, the function will return -1. Next, if a and b are equal, the function will return 0. And lastly, if a is greater than b, the function will return 1. Now, first of all, a function can have multiple return statements. So even though I did mention before that there should be no code after a return statement, that's not always the case. See, if a is not less than b, this return statement will not be executed, so the function will not terminate, and the computer will move on to this if statement. And if a is not equal b, the computer will ignore this return statement and move on to this condition. And if, for example, a and b are equal, the function will return 0 and terminate, so this condition will be ignored. Now, since this condition will be checked only if this one is not true, even though this is an independent if statement, it effectively becomes an else if, since it will be checked only if the function does not terminate here, which in turn is only possible if a is less than b. The same goes for this if statement. Because of this return statement, this if block effectively becomes an else if, and we can turn it into an else by removing this if statement altogether. So now if a is not less than b, the computer will check if a equals b. And if that's not true, the only possible outcome is a is greater than b. And since it's the only possible outcome, we don't really need to check it, and we can just return 1. Now, the main point of this part of the lesson is to show you how the return statement can be used inside functions, and to emphasize the fact that return statements terminate the function and ignore the code below the return statement, which can be convenient to use together with if statements. Alright, so we have just declared and defined a function. Let's try calling it. Now again, you cannot declare a function inside another function, but if you want to call a function, you have to do it inside the body of a function. So let's call our function inside the body of the main function. First of all, let's comment out the existing code and call our function before this return statement. To call a function, we need to specify the function identifier, which in our case is compare, and then provide function parameters inside round brackets. Please note that when calling a function, as parameters we pass actual data that is then assigned to the variables that we declared as parameters. Meaning, if we call the function like this 1 will be assigned to the variable a, while 2 will be assigned to the variable b. And inside the body of the function, 1 and 2 will be compared, and the return value of the function will depend on the result of comparison. Now, if we run the code, we'll get an error saying that we're calling an undeclared function. This error happens because we called the function in line 13, while the function is declared in line 18. So one way to solve the issue is to move the compare function above the main function, like this. And if we run the code now, we won't see any errors, but we don't see anything else either. And here's the thing. The compare function returns an int. The possible return values are -1, 0, or 1, but we do not do anything with the return value. Alright, then what can we do with the return value of a function? We can treat it as data, meaning the same way we treat variables or literals. For example, we can print it, like this. Please note that because the return type of the compare function is int, we use %d here. And now if we run the code, we will see another error. This one happens because we commented out the stdio library include directive at the top of the script. And this is just a reminder that if we want to use a function that is not present in our code, we need to include the library that contains that function. So let's uncomment the include directive. And if we run the code now, we will see -1 in the console, which means that the first number we pass to the compare function is less than the second one, meaning 1 is less than 2, which is correct. Now, if instead of 1 and 2 we pass, say, 1 and 0, expectedly we will get 1 in the console. And if we pass 1 and 1, we will get 0. So the main takeaway here is that function calls can be treated as data, and the type of data matches the return type of the function. Alright, now, does anybody remember how this whole mess began? Well, we were talking about comparing strings. So to compare two strings, we can use a function named strcmp. To use that function, we first need to include the library that contains it. To do that, let's scroll up to the top of the code and add #include, followed by the name of the library inside angle brackets. The name of the library that contains the strcmp function is string.h. And now in the main function, we can call the strcmp function. Similarly to the compare function we wrote earlier, the strcmp function takes two parameters, specifically two strings. It then compares the strings and returns an integer number that we can print the same way we do it for the compare function, like this. What the strcmp function does is it compares each character of the first string with the corresponding character of the second string until it finds a pair of non-identical characters. In this case, the strings are considered not equal. However, if all characters are the same, the strings are considered equal. So if the two strings that we pass as parameters are equal, the strcmp function returns 0. Now, let's see what will happen if the two strings are not equal by changing the second string to, say, hj. Well, in this case, I get -1. So when the first string is alphabetically less than the second string, the strcmp function returns a negative number. In this case, the string high is less than the string hj because the first non-matching character of the first string, which is I, is alphabetically higher than the corresponding character of the second string, which is j. And if we change the second string to, say, hh, making the first character of the first string alphabetically lower than the corresponding character of the second string, the function will return a positive number. And if we change the second string to, say, ha, we will also get a positive number. And if we change the second string completely to, say, by, we will get a positive number since the first non-matching character of the first string is alphabetically lower than the corresponding character of the second string. Please note that the strcmp function does not always return 1 or -1 when the strings are not equal, but it always returns 0 if the strings are equal. To demonstrate how this can be used in practice, let's take two strings from the user. Now we're going to compare the strings using the strcmp function, and if it returns 0, we will print that the strings are equal. Now, since the strcmp function is not guaranteed to return 1 or -1 if the strings are not equal, to check if the first string is greater than the second one, we check if the return value of the function is greater than 0. And if it is, we print that the first string is greater than the second. And for the case when the first string is less than the second one, we check if the return value of the strcmp function is less than 0. And if we run the code, we will see that it works the way it should. Now let's optimize the code a bit. See, instead of calling strcmp 3 times, we can call it once and save the return value using a variable. Since the return type of strcmp is int, to store its return value, we need an int variable. And to this variable cmp, we can assign the return value of the function. And now we can use this variable cmp in the if statements, like this. Here, there is no need to check whether cmp is equal 0, since if these conditions are not true, the only possible outcome is that cmp is 0. And if we run the code now, we will see that it works the way it did before. Alright, so functions can return data, which allows us to use function calls as data by assigning them to variables, comparing them with other data, and doing whatever we can do with data whose data type matches the return type of the function. And this is pretty much it for this lesson. As usual, to test your grasp on the material covered in this video, you can take a quiz that you can find on our Patreon page. The link is in the description. If you have questions or need help with the material in general, you can schedule a one-on-one meeting with me. The link is also in the description. And of course, don't forget to like and subscribe if you haven't yet, and turn on the bell not to miss the next video. And I'll see you then. Bye.